It's not often that we witness a technology redefine the boundaries of human potential. But one of these moments is now. And the technology is, of course, AI. My name is Steiner. I'm a developer relations engineer at Chrome. And in my talk, Practical Built-in AI with Gemini Nano and Chrome, I want to take you with me on a journey into the exciting world of built-in AI in Chrome. Chrome's AI mission is simple and yet powerful. Make Chrome and the web smarter for all developers and all users. All developers means web and extension developers of any skill level. AI should be easy to use, independent of whether or not you are an AI expert. And all users means democratizing access to AI for all users, not just those with access to the latest ultra high-end devices and services. One thing in 2025 is certain: AI is everywhere. And when AI is everywhere, then of course it's also in Chrome. It's actually not just in Chrome, it's built right into Chrome as built-in AI. So what's coming in this talk? First, I recap the concept of built-in AI and provide an overview of the built-in AI APIs we've been developing. Next, I'll show you some amazing use cases that our partners have realized with these APIs. And then I'll have some new and exciting features up my sleeve that I'll show you. So be prepared to see some more exciting built-in AI surprises. Oh, and legal wouldn't let me use the original Madeleine Dubois train meme, so I've just reenacted it myself. Enjoy the meme, and let's get started. The concept of built-in AI was introduced by my colleagues Kenji and Maud in their talk Practical On-Device Web AI from Google I/O last year. I highly recommend you go check out that talk or watch it again. Since then, we've well established the concept of built-in AI, reshaped the API surfaces multiple times based on developer feedback, and made some important quality improvements to the AI model. Kenji provided a first update of the built-in AI effort at the Web AI Summit in November. Again, I highly recommend you watch this talk and all the other Web AI Summit talks, in fact. But to briefly recap the concept of built-in AI, this is Chrome, the browser that you all know and love. And in Chrome, for a long time already, we have smaller expert models built in, for example, for translation and language detection, but also less visible features like notification prompt prediction to block spammy notification prompts and more. What's new now with built-in AI is that we've added a general-purpose large language model, or LLM for short. In the concrete case, it's actually a relatively small LLM called Gemini Nano. Unlike the other models, Gemini Nano doesn't ship with Chrome by default, but is downloaded dynamically on demand once a web app wants to make use of it. The reason for not shipping it by default is that while it's small for an LLM, it's still a larger resource. As a general-purpose LLM, Gemini Nano can be optimized for specific tasks like text summarization, creative writing, and others. This happens through so-called fine-tunings. Combined, the expert models, the Gemini Nano LLM, and the fine-tunings are then exposed as high-level APIs, allowing the browser to match developer intent with the best model and fine-tuning for the task at hand. This is complementary to low-level approaches for running AI models. Watch the talk Real-World AI Use Cases in the Browser with WASM, WebGPU, and WebNN by my colleagues Yuriko and Sveta for more details on those. The advantage of built-in AI are at hand. With the AI model running on the device, sensitive data never needs to leave the user's browser, which means huge benefits from a privacy perspective. When there's no server involved, this also means that running the AI model can happen entirely offline once the model has been downloaded. And you always get great performance, thanks to hardware acceleration on your device. So in some cases, you might even beat the performance of the cloud. So, with this required background checked, what are those built-in AI APIs concretely? But before we get into the details, a fair warning. All the APIs that you see have limited availability baseline status. You can test them in Chrome and sometimes they're even still experimental and have to toggle a flag in Chrome flags to activate them. With this out of the way, first there's the freeform prompt API, which is an origin trial for Chrome extensions and testable behind a flag for the web. Origin trials give you access to a new or experimental feature so that you can experiment with this feature and offer it to your users for a limited time. The prompt API is our testing ground for figuring out what developers want to use with access to an LLM. As a freeform API, you can tell the prompt API to almost do anything. First, you create a session with the LLM by calling languagemodel.create. Then you call the prompt function of the resulting AI session object, passing it a prompt like explain quantum computing like M5. If you build Chrome extensions, you could take this concept even further and create a generic explain like M5 extension, for example, for news sites. First, you need to extract the article text from the web page and get it into the extension. Then, like on the web, you need to create a session, but from an extension context. During the origin trial phase, you need to call Chrome AI origin trial language model create. The resulting session object is exactly the same as on the web, and you can call the prompt method like before. Next, after the freeform prompt API, there's the family of the writing assistance APIs. Concretely, it consists of the Summarize API, which is an origin trial, and the Writer and the Rewriter API, which are both behind a flag. Imagine a page that lets users write blog posts. You can then use the Summarize API to suggest headlines for the posts. First, you get the text of the blog post. Next, you create a Summarizer instance by calling Summarizer create, providing a type of headline and a desired length of short. You can then get a headline suggestion by calling the Summarizer's summarize function. The Writer API could help the user draft such a blog post to begin with. The shared context here is a list of things that got better. You then create a writer passing it the shared context. And in the next step, call the writer's write function, telling it to write a blog post about the world changing for the better. The Rewriter API is pretty similar, just that instead of writing something from scratch, it allows you to have an existing draft rewritten. You create the rewriter and provide it the same shared context as before, and then call the API's rewrite function, asking for the tone of the rewritten version to be less formal. Finally, there's the family of the translation APIs, which are all in origin trials. Namely, there's the Language Detector API and the Translator API. First, the Language Detector API, which serves to, detect the language of, for example, user-generated input text, where the language is unknown. You create a language detector by calling create. Next, you call the language detector's detect function, which returns an array of language detection objects, each containing the confidence and the detected language. Here, I just pick the first array entry, which contains the most likely detected language. The Language Detector API pairs well with the Translator API, which allows you to translate from a source language to a target language. You create a translator by calling the create function with the source and the target language. Then you call the translator's translate method and you get the translation. Something that humans are really good at is spotting patterns. Do you spot a pattern here? What do you see? A whale? A submarine? A sheep? From clouds to something less subjective. Do you spot the pattern here? Right. All instances are created equal. From language model to translator, they're all created consistently the same way, through a create function that in some cases has some optional options. I skipped it in the previous code samples for brevity reasons, but remember how I said the model will be downloaded dynamically on demand? So how do you know if the model has been downloaded? To allow the developer to easily check for the readiness of the model, there's a consistent way through the availability function. It responds with unavailable if the implementation doesn't support the requested task or options. It responds with downloadable when the implementation supports the task and options, and the model or fine-tuning can be downloaded. It responds with downloading when the required download is in progress. And finally, it responds with available when the API is ready to be used. Here they are again: unavailable, downloadable, downloading, and available. Consistently the same for all APIs. Beyond the base Gemini Nano model, we've also started adding fine-tunings to better address specific developer needs. Gemini Nano's architecture is wonderfully shapeable, allowing us to easily improve on challenging areas noted by developers, such as generating concise and informative headlines. We are pretty excited about this, as we've seen our summarization quality metrics improve by up to 2 digits. Subscribe to developer.chrome.com for an upcoming article with more details. These API shapes and the consistency that you just saw are also the product of the feedback the Chrome team has received from moving these API incubations into the Web Machine Learning Community Group at the W3C. All 3 API families, the Prompt API, the Writing Assistance API, and the Translation APIs, are in the charter of the Web Machine Learning Community Group, and we're working with the community and other browser vendors to make them interoperable. With this API's interoperability journey being well underway, we're moving forward with shipping the first APIs in Chrome 138. Concretely, the Chrome API is shipping for Chrome extensions. From the Writing Assistance APIs family, we're shipping the Summarize API. And finally, we're shipping the APIs that form the Translation API, namely the Translator and the Language Detector APIs. We are also moving forward with the 2 other APIs from the Writing Assistance APIs family. The Writer and the Rewriter APIs enter the origin trial phase, likewise in Chrome 138. From the start, we've closely worked with a diverse group of partners that have tested our APIs thoroughly and that have helped us clarify the use cases for these APIs. This slide contains logos of just some of the partners that we've worked with. It ranges from consulting companies like Deloitte, to travel companies like Redbus or Make My Trip, to partners related to publishing like CyberAgent or Brightsides. Check out the links in the description to in-depth case studies about those partners, as in this talk I can barely scratch the surface. Redbus is a bus ticket booking service based out of India. They use the Summarizer API to let customers summarize bus reviews, so passengers can quickly see what other passengers liked or disliked. As Redbus knows their logged-in customers, they have plans to tailor the summaries based on individual preferences, like a strong desire to have reliable Wi-Fi on board or a seat comfort. Spanish e-commerce platform Miravia has a similar use case and likewise used the Summarizer API to summarize product reviews, so users can get a summary of, say, all the 4-star reviews. Publishing company Brightsides integrated the Summarizer API into its AI-powered content management system. One of their publications, the iconic The Standard, now has personalized news summaries, for example, to summarize an article about a thunderstorm warning according to the shared location of the user. Terra is one of the largest content portals from Brazil. They combine the Summarizer API and the Translator API so the journalists can get news stories summarized in their content management system. They translate the original Portuguese content to English with the Translator API. Have the Summarizer API create a summary in English, which they then translate back to Portuguese and make it available for all users. Recognizing that content creation can be time-consuming for bloggers, Japanese internet company CyberAgent wanted to enhance the blogging experience on the popular blogging platform Amoeba Blog. CyberAgent chose to develop a Chrome extension as a way to implement these new AI features without potentially disrupting the existing Amoeba Blog website. The resulting Chrome extension provides several key features: AI assistance for generating catchy titles and effective headings, improving and editing sentences, and even drafting subsequent paragraphs based on selected sentences. Indian insurance platform Policy Bazaar built an insurance assistant chatbot that users can talk to in their native Indic languages. They use the language detection API to identify the user's input language. If it's an Indic language, the Translator API translates the input to English and forwards this query to a custom server-side model, which responds in English. They then use the Translator API again to translate the model's response back to the user's native Indic language. Traveler website Make My Trip supports customers with writing reviews. Based on a few keywords, the Writer API expands the text to a more complete review, which the customer can then refine with the Rewriter API, for example, to make it less formal. Consulting firm Deloitte is experimenting with multiple built-in APIs. They run an in-house Deloitte engineering platform for 50,000 engineers and are evaluating whether the Prompt API, the Summarizer API, and the Writer and Rewriter APIs can help with tasks like form filling, engineering onboarding, and providing feedback. But we didn't just work with big and small partners, we also looped in the developer community from the get-go and invited them to test our APIs and give us feedback. We are running an early preview program with more than 16,000 members whom we invited to test our APIs the moment the code became available in Chrome, and who bravely stuck around even when things broke. A heartfelt thank you for staying with us here. We also organized a public built-in AI challenge hackathon that attracted nearly 9,000 developers from across the world, and for which we handed out $65,000 in prizes. We had amazing contributions from developers like you, who won prizes in categories like Best Real-World App, Most Innovative App, Best Hybrid App, and more, separated into Chrome extensions and web apps. Thank you to all our participants, and of course, congratulations again to the winners. Oh, and keep your eyes open for a potential 2025 edition of the Built-in AI Hackathon. We'll announce it on developer.chrome.com, so be sure to subscribe to this feed. This all sounds fantastic, right? But of course, there's always a but, or an and yet, if you take joy in misleading people predicting your sentences like I do. The and yet here is the classic chicken and egg problem. If a feature doesn't work on all devices and browsers, developers won't use it. But if no one uses the feature, there's no reason for browsers to implement it. And this is where the Hybrid Software Development Kit comes in. But before I explain more about this SDK, let me restate the challenge. Running AI models is still a quite demanding task. Yes, the state of the art changes all the time, and advancements like early access models will definitely help. But there's an undeniable support gap at the moment, which includes the following platforms. Chrome OS will soon be developed on large portions of the Android stack, so we'll work on adding support once the transition is done. While some higher-end Pixel devices come with Gemini Nano, the majority of Android devices in the wild don't satisfy the requirements for running AI models performantly. Some desktop devices don't meet the hardware requirements, like having more than 4 GB of video RAM. And lastly, while we hope that these APIs will, in time, be available in other browsers, today they're available only in Chrome, and they're not in Chromium. Alright, so let's talk about the Hybrid SDK. It's an extension of the existing Firebase Web SDK, a platform designed to support you throughout your app development journey. The core idea of the Hybrid SDK is that it will use the built-in APIs whenever they are available and to fall back to Gemini on the server. The Hybrid SDK will be available later this year. Until the full solution is built out, we'll make a developer preview available in Chrome so developers can test it. Note that this temporary solution isn't meant for production use quite yet. See the link goo.gle/hybrid-sdk-developer-preview for more information about the developer review and the availability of the final version. Let's briefly recap what we saw so far. 4 APIs shipping, 2 APIs entering origin trial, and a new Hybrid SDK. But wait, there's more. Prepare for some bleeding edge explorations. We've seen a lot of our partners, early preview program members, and developers in general try to make use of the freeform prompt API for proofreading. As a common theme, once we know what you want to do with the AI model, we can fine-tune the model for this very task. And that's exactly what we did. So we are now introducing a Proofreader API that you can soon try out in your apps. It's based on fine-tuning the Gemini Nano model so it can deal well with typical problems you want a Proofreader API to be aware of, such as spelling issues like this missing L. It can also detect punctuation issues like this comma that shouldn't be there, or capitalization errors like the lowercase word fix that should be uppercase. The API is also trained on wrong prepositions, like this on that should be an at. How many times have you skipped a word? Maybe because you got distracted when you were writing. Here, there is an I missing. And finally, the API can detect general grammar issues, like this is that should be an R. So how do you use this API? Of course, first you need a text with spelling issues, like this. Next, you instantiate the proofreader, which, remember, consistently, as with all the other APIs, works with the create function. In this example, I pass additional options to tell the API to include the correction types and explanations for the corrections. And I prompt the API to expect English as the input language. Now you need to call the proofread function, which gives you an array of detailed correction objects and a complete corrected version of the input string. You can then loop over the corrections one by one. Each correction has a start index and an end index relative to the input string, the actual correction, and, if you've opted in, the correction type and the explanation. It may be a bit of a visual overkill, but for the sake of the demo, here is a color-coded Proofreader API demo that shows the API in action. Let's see what the API detects. Yes, of course. It should be knocking on wood, not knocking at wood. The Proofreader API will be testable behind a flag in Chrome 139 or 140. Textual APIs like the just announced Proofreader API are exciting, but it gets even more exciting. Introducing multimodal APIs. First, we are adding image support to the prompt API. This means you can ask the Gemini Nano model about what it sees in visual content. This unlocks use cases like having AI describe an image. For example, if you run a blogging platform, you can have the model make suggestions for alternative text for uploaded images that the user can then refine and tweak. Another use case is getting product description drafts based on product images, for example, for e-commerce platforms. Or you can use the model to extract textual information from images, for example, to extract information from recipe scans to preserve a handwritten recipe collection. We and our partners have been super impressed by Gemini Nano's OCR powers, especially for handwriting. The way you use images with the prompt API is similar to the regular prompt API. First, you create a session by calling the create function. Yes, right, you remember the consistency. But this time, you pass it unexpected input options with an array of input object types. Here, I pass image. Image here really means anything visual, starting from an image element to a blob of an image to an image bitmap, a video still frame, or a canvas object. In this example, I pass an image element and a canvas element. Finally, you can then prompt the API about the inputs. In the running example, I asked the model what it thinks of the recreation of a reference image that the user has drawn onto the canvas. This is the finished demo, so we can take it for a spin and draw the Mona Lisa. Here we go. That's my colleague's François' Mona Lisa. Let's see what the model's verdict is. I have to say, the model is brutally honest, but correct here in telling us that the drawing is a poor imitation of Da Vinci's masterpiece. We didn't stop at image input though. We're also introducing audio input support for the prompt API. If you have an online podcast recording app, you can use the prompt API to create transcription suggestions that a human reviewer can then refine. This API is also useful if you want to add textual search for audio segments. Say you have a long podcast and you want to let the user search for parts they're interested in. But you can also think of use cases like classifying audio, for example, to categorize an audio file archive into music styles. By now, you probably know the drill. As per the consistent API design, you create a session by calling create, but this time passing type audio in the expected inputs array. Next, you get the blob of an audio file, but it would also work with a reference to an audio element. Finally, you call the prompt method, asking it to transcribe the speech. Here's a short demo where the same colleague from the Mona Lisa demo from before, François, has recorded his voice, and he then uses the prompt API with audio input and the prompt transcribe this short audio to get a transcription.
How many times did I say the word AI yet?
As you can see, it got the message, how many times did I say the word AI yet? And that's exactly what he said. We also have the built-in AI playground, which lets you explore the prompt API with multimodal input some more. Here, I'm using an image and I'm asking the model what color the person's hat is. Both the prompt API with image input and the prompt API with audio input will be entering origin trail in either Chrome 139 or Chrome 140. It's really early days for multimodal input in the prompt API, but because it's never too early to get feedback on an API, we've worked with select partners and granted them access to a special build of Chrome so they could test the multimodal APIs. We ran several virtual and on-site one-week partner hackathons, and to give you a feeling for how hacky the events were, the instructions included downloading a model from Google Drive and hot swapping it with the regular Gemini Nano model before launching the special Chrome build. Here you can see the logos of some of the partners that took part in the hackathons. As I said, we had a mixed virtual and on-site event format at different hackathons around the globe. Nika, India's leading beauty and lifestyle destination, experimented with visual search based on the prompt API with image input to let users find fitting outfits. Chefkoch, a German recipe site, used the prompt API with image input to let users digitize handwritten recipes or recipes they photographed, for example, from cooking magazines. The API effectively functions as client-side OCR, and users can then edit the recipes on the site to fix potential problems. The Independent, a UK-based online newspaper, integrated the prompt API with image input into their content management system. It helps them to generate image titles, suggestions for alternative text, or image descriptions. Brazilian Grupo OLX used the prompt API with audio input to transcribe audio messages in their chat platform, which enhances accessibility and allows the messages to be read in more places and less time. As all the processing happens client-side, this will likely be the optimal solution for end-to-end encrypted messages. I'm still super impressed with what our partners have achieved in just 1 week, and I'm looking forward to seeing many of these use cases go into production soon. So let's recap what we've covered in this talk. First, we're shipping 4 APIs: the prompt API for Chrome extensions, the Summarize API, the Language Detector API, and the Translator API. The prompt API for web remains behind a flag. Second, we are moving 2 APIs into origin trail, the writer and the rewriter APIs. And third, we're making 3 completely new APIs testable behind a flag: the prompt API with image input, the prompt API with audio input, and the Proofreader API. And finally, we have announced a hybrid SDK developer preview to extend the reach of these APIs to browsers and devices that wouldn't otherwise be covered. So, what's next? You are next. Please go and try our APIs. Check out our docs on developer.chrome.com/docs/AI/built-in. And remember, multiple APIs are in origin trails, so you can try them on real users. Play with all of our demos on chrome.dev/web-ai-demos. If you find a bug with Chrome's implementation, help the team and file a bug at new.crbug.com. If you're interested in these APIs turning into web standards, become part of the standards effort and check out the relevant repositories on GitHub under the Web Machine Learning organization. You can comment on existing spec issues or open new ones. And of course, if you haven't already, join the early preview program. You'll hear of new opportunities to test APIs as soon as they are testable. Sign up at goo.gle/chrome-ai-dev-preview-join. And with that, thank you very much for watching my talk. It's an honor to present this joint effort on behalf of the entire Chrome AI team. I hope you have as much fun working with the built-in AI APIs as I do. If you have any questions, be sure to reach out. You'll easily find me on the internet by searching for Thomas Steiner Google. Happy hacking!